Hey everybody, Mr. Barry here again. We're taking our absolute value equations that are provided to us and we are creating graphs from that information. So previously in the last Nearpod, what we did was we had a picture and we got the equation from it. Now we're going to work our way the other way around. There's our information that we want to just make sure we're aware of at all times. We have our general form for an absolute value function. We know that h and comma k is our vertex. It would be x, y on the graph, but we know within the function it's h, comma k. And then we also know that our a value is the slope to the right of the axis of symmetry. It should be kind of interesting here for the slope in this particular problem. Over here I have our absolute value function. We got y is equal to, and there's a negative symbol. That'll be slightly kind of weird, but then we'll talk about that in a second. Then I have the absolute value, x plus 3. And then after that I have minus 2. So again, as always, the easiest thing to do, I would suggest to you, is start off by figuring out, hey, what would that vertex be? As easy as we know that the vertex is where we need to start, the concept of how we get our h is probably the toughest thing within this type of a problem. We know what we talked about here is that if we want the letter h, the best thing to do here is figure out what x value inside of the absolute value would give us a value of 0 if I plugged it in. So I have x plus 3. I'm going to go ahead and set that equal to 0. What value of x would we be able to plug in and get equal to 0? Well, let's just do one-step equation. We subtract 3 from both sides, inverse operation, and we get x is equal to negative 3. If we took the number negative 3 and plugged it into the absolute value right there, we would have the number 0. So that is what we're doing each time for the letter h. Math work-wise, that's really all we have to do. We know that our h value would be negative 3. Same exact thing as the x. Our k value, the second part to that vertex, is right here behind the absolute value. We can take that at face value, and what we see is what we get. So our k value here would be the number negative 2, which means with the h being negative 3 and the k being negative 2, our vertex for this problem would be negative 3 comma negative 2. I'll go ahead and start off by putting a dot on that. We start at the origin when we count for a point. We go to the left because it's negative 3, and then I go down 2. So right here is our vertex. With the vertex, we know that we always have an axis of symmetry, and the axis of symmetry is an imaginary line that travels right through the vertex at a vertical line. I'm going to go ahead and draw it in. It might not be a bad idea to try to draw it in, especially with a pencil, just so that you understand that it is imaginary. And at any point in time, we can erase it to kind of make the picture look a little bit easier to read. Figured out h and k, need to figure out what the a is. And we come over here for a second, and the a is supposed to be right here as a number. But right now, all we have is a negative symbol. In front of that absolute value, we have to understand there's a coefficient, and we'll see certain numbers out there, but we also need to understand that if there's a negative symbol, that there would be an understood negative 1 in the front as our a value. So here our a value is negative 1. If there was nothing in front of this absolute value, there would be an understood positive 1. Just like parentheses would have done in Algebra 1. All right, if we just see a negative symbol in front of a grouping, then we know it's a negative 1. Since our a value is negative 1, what that tells us is that our slope on the right side, of the axis of symmetry would be negative 1. Our slope is going to be negative 1 to the right side of the axis of symmetry, which means since it's a negative 1, we would go down 1 and to the right 1. from the vertex, down one, right one, down one, right one, so on. Just keep on going as long as possible there. It's going downwards, down one to the right one each time. I'll go ahead and try my best to connect the dots here. Highly recommended to use a ruler or a side of the page or something. And we want to tack on the arrow. Hopefully at this point we all understand the importance of the arrows and how that would play out if a question asked us specifically for domain and range. We also know to wrap up the problem though that this needs to look something like the letter V, but this axis of symmetry here mirrors what just happened on the other side, on the right side. So on the left side, we went down one and to the right one. Okay, on the other side, we can go down one and to the left one. Down one and to the left one. Down one to the left one. So on and so forth. So you can use that concept of slope, or, like I mentioned before, you can use the fact that this axis of symmetry is a mirror. There's one space between this dot right here and the axis of symmetry, one over there. 2, 2, 3, 3. So on and so forth, because it is a mirror. Thinking about that axis of symmetry as a mirror will certainly help us out. You can hopefully see here, in this case, the V is upside down. I have a V there though. If it's not clear to you, we can go ahead and erase our axis of symmetry. We don't need it. It's not part of the actual graph. It certainly helps us out make the graph, but not part of it. And there we have our absolute value function for this particular problem.